Find the second derivative of y using implicit differentiation. With implicit differentiation, we can start finding the derivative of both sides of the equation, and we can treat y just like we treat x. So as we go through term by term, the derivative of x cubed is 3x squared. The derivative of y cubed is 3y squared. And the derivative of 27 is 0. The one additional move we have to make here is that whenever we take a derivative of y, like this, we just treat it like x and take a normal power rule derivative. Whenever you take a derivative of y, you need to immediately tack on a y prime. Now all that's left for us to do is solve for y prime. That is the derivative of the function. So we solve for this. We subtract 3x squared from both sides and get 3y squared y prime equals negative 3x squared. And the last step is to divide by 3y squared. So we have y prime equals negative 3x squared over 3y squared. And this can be simplified. We can reduce this 3 with this 3 and get negative x squared over y squared. From the first slide, we have that the first derivative equals negative x squared over y squared. In order to find the second derivative, we just need to go through and find the derivative of this expression here. So we will call this y double prime. The derivative of a derivative is the second derivative, equals, and since we are treating x and y similarly, we will need to use the quotient rule to find the derivative at this point. So the quotient rule states we will have the denominator times the derivative of the numerator, and from there we will subtract the numerator, which is negative x squared, times the derivative of the denominator, y squared, all over the denominator squared. The denominator squared. Okay. So all we have to do now is figure out these little derivatives as we go through and start simplifying our answer. So we have y squared. The derivative of negative x squared is negative 2x, and that we are subtracting negative x squared, and the derivative of y squared is 2y. But remember, whenever you take the derivative of a y in implicit differentiation, you immediately tack on this y prime. So all of that is over y to the fourth power. That comes from y squared to the second power is y to the fourth power. From here, we have some simplifying that needs to be done. Our second derivative is almost completely in terms of x and y. We have this y prime over here that we need to turn into x's and y's. Luckily, we have a derivative up here that allows us to put y prime in terms of only x's and y's. So we need to move that and substitute it in for that y prime there. So our new derivative looks something like y squared times negative 2x. The negative minus the negative here turns into a positive. So I'm going to write plus x squared times 2y times the fraction negative x squared over y squared. All of that over y to the fourth. At this point, we need to simplify the second derivative. And to do that, really what that means is we need to get rid of this fraction. We can't have a fraction within a fraction. So in order to simplify this derivative, I want to look at just this denominator and multiply the bigger fraction by y squared over y squared. So what that does is in this first term, we're going to be distributing this y squared here. And in the second term, when we distribute y squared to the second term, it gets rid of our y squared in the denominator. So our first term over here turns into y to the fourth, right, y squared times y squared, times negative 2x. Plus x squared times 2y times negative x squared. All over, now it's y to the sixth. Y to the fourth times y to the squared is y to the sixth. And we still have a couple more things that we can simplify, like we can rearrange this first term to say negative 2x y to the fourth. We can rearrange the second term to say negative. That comes from positive times a negative. Negative 2x to the fourth y all over y to the sixth. The last few steps require us common factoring anything that we can see in the numerator. So that would be a negative 2. We can factor out 1x from both terms, and we can factor out 1y from both terms. So I'm going to factor all that out, negative 2xy. And on the inside we're left with x cubed plus y cubed. All of that is over y to the sixth power. We can then cancel one of these y's with one y in the denominator, and we can even simplify x cubed plus y cubed. Way back at the very beginning, we had the function that was given to us, x cubed plus y cubed equals 27. And this was given. So we can substitute 27 in for x cubed y cubed and be left with the following answer. Negative 2x times 27 all over y to the fifth. And when you multiply these two constants together, you get negative 54x over y to the fifth power. And there is your second derivative using implicit differentiation.